Video lesson 14.5, deriving the equation of a circle. So for this video lesson, we're just going to kind of go back and review the process of completing the square that you learned in Algebra 1. And we're going to apply that process to coming up with the equation of a circle, and we're going to take it from its general form into what we've been using, and that is its center radius form. So let's just refresh our memories first and then utilize that as we go. So if we look here, we see that we have a trinomial set equal to 0. We want to create it so it looks like this. So we're going to do the complete the square process. All right. Now we're not going to solve for x. We're just going to get it into this form. So we're going to kind of have to like stop part way in the complete the square process. So if you remember complete the square, right? We want to, first off, we want to get rid of the constant. We want to move it to the other side, and we only want the x terms by themselves. So I'm going to add the 41 over to both sides. So I'm going to look like this. Now, in order to get this to be a squared term, I need a perfect square trinomial here. All right. So in order to do that, right, we're going to add a space here. So we're going to say x squared plus 4x plus blank. And whatever we add to this side, in order to keep this equation balanced, we got to add the same thing to the other side. So how do we figure out what to add? Well, that's the b term. So we're going to take this term over here. We're going to cut it in half, and then we're going to square it. Right? So it's the b term divided by 2 squared. Right? So in this case, 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 to both sides. All right, when I do that, this right here becomes a perfect square trinomial. Which means if I go to factor this, right, I'm going to get two bubbles that are identical. X multiplies the 4, adds the 4, 2 and 2, both have to be positive. And then that would all equal what over here totals to be 45. So this expression right here can be rewritten into this one up here by simply just combining the two terms since they're identical, since this and this are the same thing, right? I can just say that one of those squared equals 45. So that's the process. Now, again, if you were doing this for solving the x term, we could keep going and get x alone, but we don't want it. We just want to stop here. We want this format, all right? If we do the same thing on this part B here, notice it's the same thought process, except it's got the y terms. Oh, this was one typo. That should be a y. For here, so I'm going to do the same process. So add over the 41. Right? Y squared minus 12y. I'm going to add a blank. Right? And whatever I add to one side, I have to add to the other. Again, how do I figure out what to put in my blanks? Take this b term, divide it by 2, square it. Now, again, you don't have to worry about the negative or positive because when you square it, it's automatically going to become positive. So it doesn't matter if you include it or not. But we will. Figure out what it is anyway. 12 divided by 2 is 6. 6 squared is 36. And that's what we got for that one. Again, perfect square trinomial. Now, you can do just a regular factoring process like we did before, or I like the fact that we can kind of shortcut a little bit here. And here's the rule. So if you just think of it as, we know it's going to be one bubble squared, right? So first one is the square root of the first term. Square root of y squared is y. Square root of the c term, or the last one, is 6. And then whatever symbol's in the middle goes in the middle here. All right. So again, we could have just done it like we did on the previous question and factored out just kind of regular and then combine them. But I can shortcut that and make it faster. If that works for you, great. If not, by all means, just go with the slightly longer version. All right. And here we go. So that process that we just did, you just did the work to actually create the equation of a circle in center radius form. Now, if we combine these two things together, that's how we're going to get that process. So if you look at part C, right, all I've done here is it's the entire thing all written out. So you've got the x squared, the 4x, right, and you're minus the 41. right? And you have the same thing over here for this one. Here's your y squared, your negative 12y, and again, the minus 41 part. So if I did this, right, if I broke this up and did this all in one step, I would get exactly this. So if I add the 41 over, right, think of it this way, right? If we move that 41 over, then I've got x squared plus 4x, right, plus y squared minus 12y. And if I add that over, it would all equal 41. And as you can see, I would be doing the blue part would be the process that we did in part A. The green part would be what we did in the process in part B. And then we could combine them all together. So if I did that, it's going to look like this. We had x plus 2 squared, right? Here. We got y minus 6 squared for that part. And then we had the 41 over here, but we moved over the other pieces, right? And when you do the process, and again, I'm just gonna, we added 4, we added 36. When we do the whole thing, I'm just gonna shortcut this a little bit. The whole thing would have ended up totaling 81 when we moved it all over. So again, it's the process of being able to kind of make that all come together. But we're going to do that, and that's the process. And then now I have this equation in center radius form. I can now tell me what the center is. I can tell you what the radius is, and we have the equation of our line. So let's do this one, a couple of these outright, just to make it a little bit easier to see. So first off, I think it's the best thing to do is get the terms together, right, from here. So first thing I see is move the constant over. So I'm going to take this 35 and I'm going to move it over. And then I'm going to look for my like terms. So I've got my x's and I've got my y's. So I'm going to write them. So x squared minus 10x. Again, we know we're going to have to get a blank there, so I'm going to add the blank in now. Plus y squared plus 14y. We know we're going to have to get a blank there. We moved the 35 over, so it's all going to equal negative 35. But again, we can't forget we need to include the two blanks that we added on the left side. We're going to have to add on the right side. This way the whole thing is balanced. All right. Now let's figure out what to plug in those. So we can take the b term, take it, halve it, and square it. So half of 10 is 5. 5 squared is 25. So we're going to add 25 to both sides. Going to do the same thing with the 14. I'll do it up here. So 14 divided by 2 squared. That's 7 squared, which is 49. All right. And that's the process. So right now, all we've done is complete the square for both the x terms and the y terms. All right. So now we do each part. So that's a perfect squared trinomial. Again, one bubble squared. Square root of x squared is x. Square root of 25 is 5. Take the symbol from the middle. Plus one bubble squared. Square root of y squared is y. Square root of 49 is 7. Symbol from the middle. And on this side, we're going to just add these all up. So I've got negative 35 plus 25 plus 49. That's going to total 39. So again, this is the equation in center radius form of our circle. And out of that, we can get two very important facts. We can find out what the center point is. That's going to be, again, the opposites. So it's going to be 5 comma negative 7 is my center. My radius is, again, this is r squared. So the square root of that, right, is our radius. And honestly, square root of 39 doesn't simplify, so that would be your answer. So again, this is what would be the information that we can pull out of it. Now, again, it might just ask you for the equation. or it could give it to you and then ask you for the center and the radius like this part did. All right. Again, this equation that we started with, this is referred to as the general equation of a circle. So that's what is up here, this example here. That's all the way it is written right now, with all the terms together on one side. That's called the general equation of a circle. All right, and same thing over here in example 3. This is the general equation of the circle. So we want to derive it to get it into that form, center radius. All right, so let's do the same process one more time just for practice here. So I'm going to add the 23 over. I'm going to combine and just have my x terms. Now they might be shuffled around, and if they are, that's fine. We just want to rewrite them so that they're all together. Plus y squared minus 6y plus blank. This is all going to equal, we've got 23 on the right side now, and I'm going to add my 2 blanks in because we're going to figure out what number makes these perfect squares. So half of 4 is 2, 2 squared is 4. Half of 6 is 3, 3 squared is 9. Whatever I add to one side, I have to add to the other side to keep it balanced. All right, perfect square trinomial. X, square root of x squared, square root of 4, symbol from the middle. All of that is squared. Plus, again, one bubble squared, square root of y squared, square root of 9, symbol from the middle. And that whole thing is going to equal, if we add these all together here, what do we got? 23 plus 13, that's what, 36? All right, so here's the equation of my circle in center radius form. So if I want, I can now determine what the center is. Take the opposites, right, because it's minus h and minus k. So to get a plus 2, I would need negative 2. And to get a negative 3, I would need a 3. So there's my center. And the radius is the square root of 36, which is just 6. And there we go. All right, so that's the process. That's your deriving the equation of a circle from the general form into center radius form. All right, so it's a thing that, again, it's all about the algebra. It's about practicing complete the square. It is something that if you're not solely comfortable on, practice makes perfect. Just got to keep doing it. It's perfectly fine if you want to do it individually, right? Do the x terms, then do the y terms, and then put it together at the end. That's fine. But in the grand scheme of it, I think it's if you just kind of get used to doing it like this with organization, and maybe even different colored pencils or something, that's fine. It just makes it a little bit easier to kind of organize your information and make things are okay. But that's what we want. We want to be able to do this on a bigger scale, no matter how crazy these numbers are or these expressions might look. And again, like I said, these equations that you start off with, like for the example, there's nothing wrong. They could give it to you like shuffled around, where the x's and the y's maybe aren't next to each other nicely. But it doesn't matter. We can always just move them around because they're just staying on one side of the equation, and we're just kind of shuffling them around with those. But that's the idea. So take an opportunity to just look over anything on the video that you need to look for in a little bit more detail. Go back, feel free to try any of these examples again to make sure you're okay, and utilize the practice problems for better understanding.